Back on you guys, but it looks like most of the groups over here. Hi, I'm Roberta Gamble, partner and vice president with Frost & Sullivan. We're a growth consulting company, and we look at many spaces around that have to do with industry, manufacturing, energy, chemicals, and so forth. And a big focus for us right now is how IoT and IIoT are really changing the world. And you know, from my own experience looking at everything from discrete manufacturing to electric power to oil and gas to other industries, you know, manufacturing really is among the more cutting edge industries. It's really amazing what is being done right now because of sensors and data and analytics and being able to get into AI and prediction across these areas. Our own research has shown that if we really took advantage of IIoT, we would be about a $9 trillion market globally, and almost half of that, about $4 trillion, would be just in the manufacturing space. So there's a huge amount of opportunity that we're seeing. And so we're going to have a great panel discussion today, roundtable style discussion with industry thought leaders from major companies in the space, as well as on the government side, a case study of how it's being implemented in different ways, IIoT is. So I'll do quick introductions, and then they'll spend about 10 minutes each talking about their roles and thoughts, and then sharing some of their thought leadership in the area, and then we'll go ahead and open up the floor to any questions that you have, and go from there. So right to my right is Mr. Wayne Allan, Senior Vice President of Global Manufacturing for Micron. Next to him, also from Micron, is Mr. Tim Long, the IT Director for Enterprise Data Science. We have the other Tim, Tim Archer, from Lam Research. He's the Chief Operating Officer for Lam. We have Maciej.
I'm used to it, don't worry.
Kranz, sorry. It gets harder. From Cisco, Vice President of Corporate Strategic Innovation with Cisco. And then we also have Mr. Yi-Hsen, Gian, who is the Regional President of the Americas for the Economic Development Board of Singapore. And we've actually had the pleasure of Frost & Sullivan to do some great work with Singapore and smart cities and so forth. So we're really, really happy to be here as part of this conversation. So, Wayne, we'll put the spotlight on you now.
All right, great. Well, thank you for coming. I wanted to start with a little bit of a background or an understanding of Micron and our global manufacturing footprint. We've got 13 sites that are distributed around the globe, so we've got a pretty broad footprint in the global manufacturing network. We've got about 20,000 people. We're in many different sites in Asia and in the US. So that distributed network really drives a lot of challenge when it comes to learning and making sure that we're sharing those lessons across sites and using a common platform and common data. That has really driven us to embrace big data and embrace Industry 4.0. In addition to that, we're in a very challenging industry, as you know. We've got, as we're constantly driving more and more bits per wafer or shrinking our feature sizes of all of our devices, it's becoming more and more challenging to do so in a cost competitive way, because we're adding more and more processes, so cycle times will tend to get longer, capital equipment costs will go up. So there's a tremendous amount of pressure on cost and efficiency needs for that. It's obviously there's a lot of higher expectations too with some of the new applications that we're going into, where we're building system solutions and working with automotive customers who expect these are our life systems, if you will, when we're talking about memory that goes into an automobile and helps with driver assistance. You got to make sure that the quality is at exceptionally high levels. So that also puts some pressure on us to make sure the quality levels are very high as we're adding to some of these other complexities that we have as we continue to drive new technology. So how do we stay competitive in that? It's obvious on a couple of key areas for us. Process technology is always something we put a lot of focus and innovation, as well as design and designing products that our customers need. But in addition to that, in the last several years, the doors open wide for us in manufacturing. I mean, we've always had this opportunity, but with the kind of data we have access to now and the computing power that we have, smart manufacturing has become a tremendous opportunity for us within our manufacturing organization to really start adding even more value when it comes to innovation in how we take some of these challenges we have and overcome them. So in 2013, we set out to pull all of the data off of our tools and pull them into a central database, a central cluster. And what we've done is we've connected our tools, we've connected our processing tools, our facilities information, we've connected in our metrology and yield data that we have. So all of that into a big cluster. In addition to that, we've gone in and worked with suppliers and asked for additional sensor information, because you can imagine the kind of data that comes off these tools. There's all data-rich environment that's coming off these tools, but in addition to what we're used to, we were also able to take things like acoustic data off of a tool so we can hear what's going on in a chamber and digitize that and compare it digitally against something that is normal, so we can identify aberrations in processing through acoustic type of information. Same thing with visual aids, with like thermography, where we're looking at, we can be looking at a busway on an electrical panel and see when the temperature starts to change, so that you may have a breaker that's going bad or something that's going to happen that could impact you. And you can take that data again, digitize it, and compare it to a baseline. Vibration data is another thing. So there's a lot of, not only is there a tremendous amount of data that comes off these tools, but we're adding even more features to be even more data rich. And then taking that and using that data to be able to do many different things. One of the things we're able to do, I think, exceptionally well right now is do a lot of the tool management outside of the fab, where we have a remote operations center now, because we can connect into the tools and do a lot of the management of the tools from a remote operations center, where we have we got screens up in front of our technicians there and our managers there, and they can monitor the fab and change the scheduler. They can do different things to manage the facility right there remotely, and then of course have a chance to interact with each other more effectively, because they're all together rather than scattered across a large clean room. We also are using all this data for enhanced analytics and visualization. So we have an engineering database and a system that our IT guys have helped us create, engineering operations dashboard, that allows us to reduce inefficiencies and look at optimizing sequences and changing the scheduling based on WIP profiles in the fab, look at Gantt charts on tools to see if there's an inefficiency going on within the tool that you might have to do something with the robotics. A lot of data that you can visualize now, put up in front of our engineers, so they can quickly identify opportunities for improvement. In addition to that, we have the ability to do process tuning, where when you start to see a drift going on in a tool, you can adjust it automatically so that you don't end up with a scrap or a quality event, that you catch downstream, but you can catch the tool drifting and adjust for it real time. Machine learning, where we can do predictive maintenance. You can take all this analysis off a tool, and then over time, as a tool fails, you can go back and look at what is the fingerprint that led you to seeing that was going to come, that can help you predict that that's going to happen, and then shut the tool down before that happens next time, because of the fingerprint off all the data off the tool will tell you when that tool is going to fail. And so it takes a lot of analytical power to be able to take all of that data off the tool and then be able to predict when a tool is starting to have issues before it goes down. In addition to that, we're able to take image data, again, digitize it and compare it to standard, and do some image recognition where we can identify certain types of defects, classify those defects quickly, and then train the system to be able to then see the fact that this defect came up, and then immediately flag an engineer that what tool it is causing that defect, so they can go and adjust and work that tool. So very, very fast learning and opportunities there. So we created a data science team with all this data-rich environment. We need data scientists. We need folks that are used to taking massive amounts of data and looking for this type of correlations that we can do to identify the opportunities here, and in some cases writing algorithms that help us adjust the process based on the data that we're collecting. And this data science team has, since its inception back in 2013, has had more than 2,800 major wins. We're tracking that, and a win is when somebody creates a data science opportunity, and it's shared across the network because it's good enough that it's accepted within our engineering community as something that everybody wants to adapt because they're learning quicker and able to improve yields and cycle time, et cetera. Those wins have led to faster yield maturity over the last 3 years for us by 25%. We're getting from the time of introducing a product to ramping it to yield maturity, we've seen a 25% improvement, and much of that is being fueled by this this Industry 4.0 opportunities here. We've had about a 10% increase in output and 35% improvement or reduction in quality in excursion and quality events. So it's been tremendous for us. We're continuing to invest in it because it's bearing a lot of fruit. In addition to that, the collaboration opportunities with our supplier is obviously, there's a tremendous amount of opportunity there. Tim's here to speak to that, and we're continuing to look for additional sensors, additional tuning knobs, so that we can adjust. Even some processes may be adjusted for deviations in other processes. In other words, it may not just be to control that specific tool and process, but when you're going through a photolithography process, you may want to adjust based on a film uniformity that you can see within the scanner. So there's all kinds of opportunity to play off of the integration of our process and continuing to improve yields and quality. In addition to that, I think the expertise that our suppliers have on the equipment can be coupled with our expertise on our fab data, and we can really have some great solutions working together on these opportunities. And we've seen that, seen a lot of this. A lot of these wins are being enabled by our equipment suppliers. IT, clearly plays a big role. We couldn't do any of this if it wasn't for our IT team being able to take all of this data, prepare it and clean it, and Tim can talk about that. It's not a trivial thing to petabytes and petabytes of data. It's a lot of data, and in order for this to be consumable for the engineers on the floor, it takes a lot of work. And so I guess in closing, I would say that I've not seen this type of opportunity in a while, that all of this data and computational power is leading to great improvements in an environment that we have a lot of pressure on costs and cycle time and quality, and we're actually not only improving our ability to perform at another, whole nother level than what we've been able to in the past, even with all of these challenges kind of pushing us into an even more challenging environment. And I think that we've only maybe just started, really. It's 3 years old in Micron, really, and I think it's a pretty nascent opportunity that we're still gleaning a lot from. So I think we're really just getting the journey started.
Thank you. You caught the points that he asked you to
expound
upon, right? Okay.
Yes,
Tim,
well,
please.
also I'd like to thank everyone for being here today. It's if for no other reason, it's nice to get out of Boise's 100-degree heat for a couple of days, so enjoy the weather here. Thank you for all the compliments on the IT organization. My name's Tim Long. I work in IT at Micron. I direct our enterprise data science team. My team exists within an overall analytics department within IT. So my peers in our organization are some of the people that really deserve the thanks for the work that they've done to enable our big data environment and all of the great projects that Wayne had mentioned. And I'd like to color in just a little bit more of the story that Wayne told with a little more technical information if anyone is interested. So as Wayne said, in about 2013, Micron really embarked upon this adventure into smart manufacturing, or Industry 4.0. And this was about the time that big data was starting to come onto the scene and be something that nobody really understood. And so our IT and manufacturing organization really spent quite a bit of time exploring what these new technologies were. Every day there was a new animal introduced into the zoo, and of course we had to check it out and see what its potentials were to Micron. We quickly settled into, I think, what is an interesting strategy that Micron uses to enable the type of analytics that Wayne had talked about here. The first is we have what we call our dual ingest strategy, where we have two different big data environments, one hosted in the US and an identical environment hosted in Asia. And the idea behind this is anytime these data come off the tools or shop floor software, we send it to both locations. Okay, so this gives us the ability for the 13 manufacturing facilities that Wayne talked about to be able to compare their processes right next to their peer processes from other manufacturing facilities anywhere in the world. And that's built within our Hadoop environment. Today we have about 250 nodes within each of these clusters and about 10 to 15 petabytes of data and growing, of course. We've also recognized, though, the need to provide a way for engineers to access this data in a very quick way. So Hadoop may not be known for its speed for accessing data, so we also have pursued a massively parallel processing data warehouse where we replicate much of our manufacturing data within this environment as well, where engineers can access this using traditional tools that they're accustomed to, like SQL, for example. So this is a big engineering challenge, and Micron IT employs dozens of data engineers across the world that are constantly battling with these fire hoses of data flowing from all the different manufacturing systems into these data warehouses. So that is a challenge for us. Micron has always had a strategy where we'd like to democratize data. We'd like to give data to the people who can use it to improve the business. So as we have developed this environment, it's important that we do this, but we account for proper security. So that is a challenge, but we have what we believe is a strong strategy to protect our intellectual property where necessary. And I'd also like to mention that to provide the data in an easy, accessible format, we leverage what's known as a data vault methodology. If those of you may be familiar with sort of the next wave of how we model data within a data warehouse. My team was created about 1.5 years ago in recognition that we had all these great successes from the manufacturing area of bringing data science to manufacturing processes. In the recognition that Industry 4.0 may not just be about manufacturing, it's not about just a smart factory, but really a smart company. So how can we bring machine learning to the other areas of the business? So about 18 months ago, my team was formed to bring machine learning, predictive analytics, simulation to other areas of Micron's business where we've had great success. Some of those projects that may be of interest are related to our demand forecasting. So where we have developed a machine learning model that generates hundreds of time series forecasts for which products our customers are likely to buy and when. And of course, any improvements we can make to this demand forecast signal pays dividends, because we're making the right products that our customers want at the right time, and we're not building inventory of the wrong products. So we've seen gains from the machine learning implementation of 15% accuracy, translating to over $80 million of improvement in our revenue or savings. We've also used machine learning in the prediction of some of the holds that Wayne had mentioned, where we do have excursions from time to time, or we may have a different quality-related incidents. We'd like to be able to commit to our customers when they'll receive the product, so we use machine learning to predict the duration of those holds. And then lastly, I'll mention a project where we are helping to improve the availability of raw materials within our manufacturing process by taking a probabilistic view to which materials will be required and what the daily probabilities of stockout might be. So 3 different projects there that I think we've had pretty promising results with. So my team really sees a tremendous amount of opportunity across the business, and I'll close by saying that, again, I think that the smart manufacturing opportunity is not just about the shop floor, but I really think there's tremendous opportunity for machine learning and data science across the business.
That's actually one of the questions I was ready to ask you later, is how you're using it across the organization. So I don't know if we'll go into that or not, but that's interesting that you bring that up.
Okay.
Tim, please.
Great. Well, I'd like to not only thank you for being here, but also thank Micron for the opportunity to come and talk. It's a really exciting challenge for us as an equipment maker. I will bring us back to the shop floor because that's what we do. I'm not sure how much you know about Lam, but just in case you don't, we are a leading provider partner to Micron in their mega fabs. It's the whole idea of Industry 4.0, smart manufacturing, addresses some of the big challenges we have as not only as manufacturing become more complex, process windows, what we have to achieve on our equipment has become more and more stringent, clearly. And at the same time, we have tremendous demands for cost of manufacturing improvements year on year. Wayne talked about maybe one of the biggest drivers, the amount of data, and Tim as well, the amount of data that's being generated off of tools and how we're dealing with that. It's kind of a virtuous cycle, I think, because that data has to be stored, which drives the need for more chips. And clearly this massive need for storage, the increasing need for greater compute power to deal with all that data is driving the need for feature shrinks that Wayne talked about, is driving the need for bit density improvements on the storage side. And I would have to say it's a very exciting time to be an etch and deposition equipment provider, because our technologies turn out to be right at the core of enabling both the feature shrink through our work on multi-patterning and also enabling bit density increase on memory through the fact that we provide the key steps for 3D vertical scaling. And so, like it or not, that's why we find ourselves taking up quite a bit of footprint in the Micron fabs, and therefore having quite a burden on our shoulders to improve the manufacturing efficiency. We've partnered with Micron now on some projects that Wayne spoke about, but I'll try to give you a little bit more detail. On one of our tools today, I mean, if we look at the evolution of the system design, if we go back a number of years, I mean, we would control primary recipe parameters on the tool. Today, the tools, typical system can have hundreds to some of our systems, maybe as many as 1,000 sensors on a system. Those sensors can be generating data anywhere from 1 data point per second to 50 data points per second. And so as every wafer is processed, we're generating gigabytes of data, thousands of data points per second, and we need to find some way to make use, not only store that data, but also to make use of that data in an effective way. I think it generally defines the idea of big data when you have that much data coming off the tools. In a mega fab, we can have hundreds of these tools installed in the same fab. And so it raises a big challenge for us relative to how to install those pieces of equipment, get them qualified, and ensure that those tools match and are producing a distribution of process result that helps to achieve the ultimate yield expectations of the customer. So I really look at what are we doing with all of that data versus what we used to do. And maybe we start with just the installation and startup of a new fab. As I said, we can have hundreds of process modules running the same process in a given mega fab, and the time required to install those tools and match one chamber and its process result to other chambers has been historically a rather labor-intensive process. And as those process windows have shrunk, as we go node to node, the time and labor required to match has grown to almost where it's an unmanageable problem for us. We have several thousand engineers out in the field working with customers, starting up and qualifying and maintaining tools. That's not a scalable problem as manufacturing continues to move forward. So we're partnering with companies like Micron to use that data to create baselines from those hundreds of sensors on the tool to allow us to quickly identify why tools don't match. And as an example, in a fab like Micron, we've been able to reduce the time to install and qualify and match process performance across the fleet by as much as 2 weeks. So somewhere on the order of 21 days down to less than a week. When you're talking about billions of dollars of capital investment in a fab, 2 weeks is real money. And it shortens the time for Micron to become productive, and shortens the time to, as Wayne said, the yield maturity for them. So we've found that to be one way in which we can add real value through the use of the data. The second is the lowering the cost in general of sustaining the fleet of tools. Again, the number of people we have to deploy to ensure that every tool stays within its tight distribution, ultimately that cost ends up somewhere in the cost of manufacturing of those chips. Using big data, we've been able to pull a lot of those people out of that process. The systems, Wayne mentioned a couple of the key buzzwords right now: predictive, preventative maintenance. The tools should be able to identify when certain parts are starting to wear out or need replacement. And we do that using a lot of different sensors, as Wayne mentioned: acoustic, thermal, flow, pressure, RF. Many of these sensors are in there to identify different parts of the system that may be starting to gravitate out of spec. That's a huge value for us, not only from its ability to control yield, but again, we don't have to have so many people, and we don't have to use so many wafers and so much metrology continuously measuring and monitoring. The system can now do that itself. And while we're starting to actually, while we're at the very beginning, we're starting to evolve into even maybe the next space, which is quite exciting, which is to start to have self-maintaining tools. So we've actually just introduced a capability on one of our systems where the tool actually can take the data coming off of the tool, determine that a part needs to be replaced, and the robotics inside the system actually can get the new part, put that part into the tool, and the tool just keeps running. So again, if we can incrementally increase the availability of the tools by a couple of % by not having those tools down, again, on billions of dollars in investment, a couple % is again real money. And so predicting failures, having tools that start to self-maintain, I think that's a tremendous opportunity for us. So just to maybe conclude, there was a really interesting point made about data protection and security. I guess I wanted to follow up on. We've had a fantastic partnership with Micron, relative to data sharing. Neither company, whether it be the chip maker or the equipment maker, nobody actually has all of the data they need to solve this problem. So it does require a partnership. I think if there's one thing that's going to be a roadblock to kind of the full realization of machine learning and smart manufacturing, it's if we run into a roadblock around data sharing and IP protection. So far, so good, but that is one of the areas in which I think we need to make sure that doesn't become an impediment to equipment suppliers and chip makers fully sharing the results. So with that, I'll turn it over.
Thank you. So kind of call to the industry to be aware of this and maybe coming down the road. Good.
Perfect.
Segue to Cisco.
My name is Maciej from Cisco, so I'm apologized by the funny name. And I apologize for being under the weather a little bit. I was actually in Singapore, and the long 16-hour flight, I think, did it to me. But just some background. Cisco, we've been involved in manufacturing and sort of broadly in IoT for probably 20 years or so. But we started focusing on this area a lot over, I would say, last 10 years. And the major driver that I think drove us to focus on IoT, it wasn't just that every device was getting connected, right? That's sort of the obvious way at Cisco, we connect things. It was really a shift in the buying center. We traditionally have been selling to IT and service providers, sometimes to consumers. But roughly 10 years ago, we started to see the line of business actually becoming a major buying center for technology. For the reasons that were discussed earlier. And the consequence for Cisco and for a lot of technology vendors have been that these people that run the businesses, they actually don't have much focus on technology. They focus on solutions and how we collectively can develop solutions. So from that perspective, Cisco's manufacturing and IoT strategy has been, in summary, developing horizontal modules and tools, but also using these tools to go vertically to market with specific solutions. And actually, just a shameless plug, so I wrote a book I published a book a couple of months ago around IoT, and when you think about IoT, and Thomas, you heard me about it earlier, we sort of see four broad sort of use cases in manufacturing and other market segments, and some of them were discussed already. So one of them is around just connecting all the operations in your manufacturing and broadly in your operational capacity. Lots of great examples from Harley-Davidson to Pepsi and others that are realizing savings on average 20-30% by just optimizing their operations. Remote monitoring, remote asset management, or remote operations, another great example of just reducing costs. Thirdly is predictive analytics, and we mentioned some examples already, but for example, we work with Fanuc on near zero downtime kind of a solution that not only creates great savings, but also creates opportunities for new business models, and then predictive preventive maintenance as well, that are probably the most challenging and difficult systems, but also I think the most the ones that I would bring the best results. But I think that and you may be surprised, like, why is Cisco, we are the infrastructure vendor, we talking about these solutions, but that's basically what our customers want to buy from us. When you think about customers that visited Cisco, last year, roughly 70% of these customers were actually line of business folks, people that run the business, often together with IT people. But it also drove us to sort of rethink how we organize ourselves around this IoT opportunity. So a couple of years ago, I actually ran the IoT business unit for Cisco, and then we decided that IoT needs to be embedded into every piece of what we do. And we also invested at that time $1 billion into sort of IoT-specific capabilities, starting with vertical go-to-market, right? Starting with solution development capabilities, with partnering capabilities. No one company can deliver the whole solution. We all work together in developing the solutions, providing our own capabilities and our own expertise. Advanced services and professional services. We actually firmly believe that IoT is actually driving the shift from sort of a custom, often expensive yesterday technology kind of model into an open ecosystem where hopefully you can reuse 80% of capability and only use 20% for sort of custom work. So it actually is a big benefit for customers as well. So overall, if you look at manufacturing and IoT, we count that we have around 14,000 customers who have been using Cisco technology and a combination of our solutions. But in addition to being sort of the vendor solution provider and partner, by the way, increasingly our customers want to co-develop with us, not just buy solutions from us, right? So, and the tricky part is here, how you co-develop the solutions without going custom, right? So how do you actually use the IP and IPR in a smart way? But we also obviously heavy users of IoT and technologies ourselves. Just maybe one example, in one of our plants in Malaysia, with one of our logistics partners, we looked at the operations of the plant and we thought, okay, well, are there any opportunities for cost savings from the energy consumption? So we installed 1,500 sensors around the plant and started sort of measuring and optimizing. And the long story short, by using the sensor technology, the data coming from these sensors and energy management software, we were able to reduce 20% of energy consumption just in a matter of months, and now we are targeting 30% reductions. So I will finish this, which may again sound funny from Cisco, but I fully agree with what was said before, which is IoT or IIoT or Industry 4.0, whatever the label we put on the trend, it's all about data, right? About and the real-time data. And from that perspective, we are seeing, and we've been driving a huge shift in the architecture. When you think about the first generation of clouds, right? When all the data sort of goes to cloud for processing, usually batch processing. What IoT is enabling is now much more real-time analytics, and we've talked about some of the examples. But the consequence for it is that we are starting to see increasingly distributed clouds, what we call fog computing or edge computing, where, especially for real-time analytics, when you think about, let me use a non-manufacturing examples, O-rig, 5 terabytes of data per day for some of the large O-rigs, connected vehicle, especially when you get to level 3 or more of autonomous vehicles, generating 4 to 6 petabytes of data per year. And by the way, in 2 years, every vehicle will be connected. Or every new vehicle will be connected. So these huge loads of data are sort of driving the shift for us to, instead of sending all the data to the cloud, is to build the distributed systems when we process the data close to the source, in the plant itself, for example. And we connect these systems to the cloud so that when the policy comes, for example, from the cloud, give me, let's say, analyze all the data coming from, let's say, temperature sensors, but store all this data and index it locally, but only send me the alert or exception when temperature exceeds certain thresholds. And so these kind of systems have huge implications for how we build the infrastructure as well. The second area, and we've touched on it as well, which is security and IoT security as well. We've seen a huge shift in approach of the industry into security from what I would call often the sort of security by denial or security by obscurity, right? So hoping that my infrastructure or my plant is not connected to companies realizing that of course they're connected whether you like it or not. And by the way, all the use cases that we've talked about require the data to flow from the plant to the IT infrastructure to the cloud, right? So now we actually have seen quite often chief security officers actually taking ownership for not only IT side of the house, but also operational technology side of the house with comprehensive architecture based on policies that focus on before, during, and after. And that's sort of, from the Cisco perspective, that's sort of what we see as sort of any of the values. So building security architectures, building the fog architectures, enabling scalable data capabilities that our customers can use to improve their operations. Thank you.
Thank you for comments on collaboration in particular. So,
all right.
please.
First of all, my name is Yi-Hsen. I'm from the Singapore Economic Development Board. I'd like to first thank Micron for this opportunity to share a little bit on Singapore's perspective on Industry 4.0 or what we call advanced manufacturing, actually. And perhaps just to set a bit of context on where Singapore is with respect to manufacturing. Singapore has been pursuing manufacturing as one of our key economic activities for over the last 50-odd years. EDB has been championing it since 1961, pre our independence. Today, manufacturing accounts for about 20% of our GDP and employs slightly over 500,000 people in Singapore, of which electronics is a very, very substantial proportion of it. Today, I think across the 20 different fabs in Singapore, we have 1 million wafer starts every month. That's the statistic that we've compiled. And just one last bit of trivia with respect to manufacturing. By our estimates, one out of every 10 chips in the world is actually manufactured in Singapore on an annual basis. So we do feel that Singapore has a substantial sort of investment and vested interest in the manufacturing space, especially semiconductors. Moving on to the topic of Industry 4.0, which is what we are focused on today. I think we do see many different technologies coming out of the research institutes and so on, whether it's additive manufacturing, companies that have invested in Singapore and are present and continue to be competitive and ride this transformation. I think for us, our ambition is to make sure every plant in Singapore is globally competitive, if not the most competitive globally from Singapore. But to do that, I think that there's a couple of different things that needs to be done, at least at the policy level. And I feel that we have 3 different topics that we really need to address. So one of the big efforts for us is basically to build an ecosystem of both adopters of the technologies as well as providers of the technologies. I mean, from the supply side, players like Lam, Cisco, definitely critical partners that we have present in Singapore. Besides that, I think you need a whole breadth of different players. For example, we have Amazon in Singapore from the control side, starting up a pervasive sensing COE. We have players. Just yesterday, I think Siemens announcing a digitalization hub in which they will address topics like healthcare as well as advanced manufacturing from out of Singapore. And this should provide the seeds for different companies to adopt the technologies into their manufacturing shop floor, making themselves making their plants more competitive. So on the demand side, I think Micron has been a great partner for us and a great example. I think you mentioned 2013. I think that's when around the time as well, Micron started the big data team in Singapore, and I think over the couple of years it's got a very nice size. And I think I like to think that actually the Micron team in Singapore is probably the most advanced manufacturing big data team in Singapore. And I think that's an example of a plant in Singapore that has taken the opportunities afforded by the changes in the technology and built capabilities in advance, and taken the collaborations across with the different partners and making themselves much more competitive and being able to tackle the opportunities. I think with the ecosystem of players in Singapore, that's where the collaboration can happen. And I mean, obviously, it requires different types of background. The backdrop is obviously a strong IP protection regime, reasonable data sharing policies across both companies as well as at the legislative level. And with that, then the collaborations can happen in a much faster way and benefiting the various players. The second big area that as a policy, from a policy perspective, we do believe in is to invest strongly in the technology. In terms of research and development, we will invest. We have a big master plan that stretches 5 years and billions of dollars. The stable political environment does allow us to plan across election cycles and so on. So that's one of the things that we have the good fortune to do in Singapore. But just a couple of highlights in terms of public R&D. We will invest 450 million Singapore dollars just on the national robotics program. We will also invest another 150 million Singapore dollars on AI.SG, which is our new effort in encouraging the development of new AI, machine learning, as well as solving grand challenges in terms of AI topics in Singapore. Lastly, and perhaps the most important area that from a policy perspective that we are trying to tackle is the manpower. I think that across the spectrum, manpower is always an issue when such transformation happens, both from the new leaders in terms of the new technical expertise that's required to help companies as they embark on the efforts to, whether it's to build the Hadoop platforms or to start creating the machine learning models. These are all expertise that are very important, and from a Singapore perspective, we will invest from a curriculum at the sort of pre-employment education, as well as what we call continuing education and training, or what we call professional conversion programs, where we enable engineers, let's say from a slightly adjacent industry to go through a 3 months or a year course just to get, so that they can quickly upskill into the relevant area and be functional quickly. And then the other spectrum of manpower is always displacement. There will always be worry as new technologies come on board, some old jobs will go away, and I think that's where as a government we are also paying attention to where are the displacements likely to happen and what can we do in terms of, again, training and education to enable the displaced workforce to find alternative employment, whether is it coding classes, upskilling in terms of other areas, and movement into different industries. So that's on the manpower. I think the ecosystem of players, the investments in the technology, and as well as the investments in manpower and the workforce are the 3 critical success factors as far as pushing our ambition to make Singapore's, the plants in Singapore the most globally competitive ones in their own networks. And with that, I think, I hope that many companies will tap on some parts of Singapore to go on their journey in terms of the transformation in Industry 4.0. Thank you.
Thank you. Thank you, gentlemen, for all the introductions. I guess I have one question just to get us started before we open up the floor. And a few of you had mentioned collaboration, certainly between Lam and Micron, and then Cisco across different companies. I was wondering if I could turn that question over to Micron, either of you, and just what are your thoughts on collaboration or examples, or where are some of those gaps that Maciej said you can't do it all. So what are your
well, I would like to
thoughts on
just leverage off of the discussion with EDB. We've had a lot of, I think, great collaboration and looking for opportunities to invest appropriately to where we can get a lot of the basic tasks that were being done historically in manufacturing to be automated. And in doing so, then working closely with the universities to retrain people and make sure that we can repurpose those people so that we're continuing to provide upskilled opportunities for them to add even more value into the company. So that's an example of something that you really need to have the collaboration there to make sure that we can leverage from a policy standpoint and also just from an education standpoint, utilize the universities that we have in Singapore. One other example of that would be the encouragement, I think, by the efforts that I think EDB is driving is to encourage the universities to provide new training and new education around big data and data analytics and data science. So that's relatively new field. I mean, there's always been a lot of analytical science that we've had for decades, but this is a whole new level of focus for degrees for data scientists, and we're hiring those folks and putting them to work, and it's making a big difference for us.
Comments anyone would like to make on the topic?
It is sort of an interesting shift, right? Where maybe in the past collaboration was more of a nice to do, and now it's a must, right? And which actually drives a lot of interesting shifts in from a technology perspective. For example, questions of standardization. And interoperability, right? We cannot really effectively collaborate unless we're speaking the same language from the data perspective. And this is, and we are here at the SEMICON event, right? And that sort of symbolizes how the industry is coming together. But I also think that a lot of us actually have been very involved and active in standard bodies, from IEEE to IETF, as well as consortia and even regional standard bodies. And I have to admit that 10 years ago, it'd be hard, for example, for us to imagine operational folks and IT folks and vendors actually. I kind of joke that we used to be on different planets, and now we're actually working together. When you think about talent, it's also interesting that all of us are actually hiring the same folks, right? So the same kind of classes of people. So every industry is becoming a digital industry. Every industry is becoming every company is becoming sort of a technology company from that perspective. But I think that that's actually very exciting from my perspective, because it's we sort of crossing the industry boundaries and even the sort of geographical boundaries as well. And that's probably the most exciting aspect of IoT is that across the industry boundaries, we are all collaborating together.
Great, excellent points. See if we have any questions we'd like to start going to the other. Gentleman right here, please.
I have a question, Wayne. I just want to make sure, see if I heard it right. Did you say how much data you had? Was it 250 terabytes or petabytes?
No, it's 16 petabytes in our Hadoop clusters.
Yeah, there's about 14 at each location petabytes, yeah.
So how much?
14 petabytes in
14.
each of our locations, yeah. The 250 that you were quoting was 250 nodes in the cluster.
Okay, thanks.
You're welcome.
I have a question for Tim. Does Len produce an SDK for your IoT? I mean, for your integration. I mean, what do you provide to Micron, I guess? So I'm trying to find out on the software, or do you have to create a completely new software internally to understand the data?
I'm hoping you can comment on
I already
what
said
you
he's the
provide.
software guy, I'm not the software guy, but, no, in general, I mean, I can speak to what we provide and then maybe they figure it out, but, you know, we are developing the algorithms for the use of our data. And what we collaborate with Micron on is, and there's maybe two different elements, and that's back to this collaboration point. One is we create algorithms that are designed to ensure that our tools, independent of Micron's data, actually perform as we expect. So that was the matching and qualification application I talked about. So that's where you know that the first tool we delivered to Micron on which they developed their processes, every tool we deliver for the fleet after that matches. We actually don't really need Micron data or engagement for that. There's a second level, which is where Micron and Lam collaborate with output data. It might be a critical dimension, a trench depth, you know, something that is what they want to have measured on the wafer or ultimately yield. And in those cases, that's fed into the machine learning algorithm, and we create an algorithm which fits somewhere on the order of 100 to 150 sensor outputs that are selectively chosen because we do have some intelligence about what affects what. So we don't have to process all 2,000 sensors. And then that output, that fitting algorithm is shared between the companies. And that's where I talk about this, the key being this, how do you really work out in the long run the IP and data protection is because there is tremendous, we all now know data is quite valuable, and the creation of the algorithm is also quite valuable. And so far, I mean, there's a lot of trust between the companies about how that gets used, but ultimately, knowing what affects yield and knowing what controls our parameters, that's something that actually is, as I say, quite valuable to the companies. Now, maybe I'll turn it over to the other Tim, because I think there is a challenge when I talk about data protection, and there was this fog computing, and where does the data go? You know, I do think that kind of on-premise, somehow something close to our systems is where the data will have to be shared. And I believe that what will end up happening is all of our data will go into their 14 petabytes and how we link in there. In fact, we're writing our code to be able to interact with their system. And exactly how we do that, that's beyond my knowledge, but our intention would be to put it into the on-site or this dual site system.
Just that would be before we start. Has this affected the use market at all in which the tools actually have to be specified for a certain customer?
No. As far as we see, there's it's independent of that.
Yes, so unfortunately I won't be able to add a lot of technical color to this particular question, but as I understand through my peers that I collaborate with, that there are pretty good gateways and standards communications coming from our tools that have been around for quite a while. They've been producing data for a long time, and semiconductor manufacturers have been collecting this data for a long time. So the challenge here is that now we're adding more and more sensors and collecting them at higher and higher frequencies. So the standards, I think, are as far as I'm aware, are in pretty good shape.
I think we have, for the most part, pretty decent standards, sex-gem communication type of
Correct.
standards that we have in our industry that allow us to get the data out. It's then preparing that data in the right time sequence and understanding how many of those data points you want to collect and clean and put into your data versus just dumping everything wholesale into your. That's the trick for us, is cleaning the data, having the appropriate timestamps on it, and making sure that it's usable.
And so everything's internal, that is the answer. You don't use like Splunk in order to do the data scrubbing and stuff like that.
Go ahead.
Right, so we collect it all internally today, yes. And for some of the reasons that were mentioned here, where security is very, very important to us, and we're working through how do we leverage more cloud technology, because we do see great potential there, but we need to do it very carefully.
Oh, a few other hands.
How much appetite would there be in our industry for someone like GE to come in with their Predictive product and do just what we're talking about here?
Well, I think, we're always looking for partners to come in and provide solutions that we can, take this data and learn faster and create the kind of process controls, the advanced kind of process controls and predictions that we need to manage our line more effectively. So we're always open for anyone with new technology and ideas to come and talk to us.
But if I may just jump in, I think the semiconductor industry is probably way ahead in terms of the application of big data and so on compared to many of the other. I mean, in Singapore, we've seen, like, for example, the partnership between Emerson and Chevron Neuronite, and we have a couple of other different partnerships, and those tend to be a little bit more basic in the sense that they're still trying to get up their proper IT infrastructure, put the sensors in place to measure whatever is it that they're trying to measure, whereas I think in the semiconductor space, it has gone to the point where you're really collecting petabytes of data. So
Yeah, where we have done a lot of partnering is on visualization techniques and visualization software that allows us to take this huge amounts of data and turn it into something more visual that you can immediately identify that there's an issue. So there has been a lot of partnering with different software and technology providers on visualization technology.
Okay.
Just a very gentle question. What surprising or challenges did you find when you analyzed all the big data? Something that you didn't anticipate and it just showed up?
I think we'll turn that over to Tim, perhaps.
Jim,
Yeah.
why don't you jump on that? And I've got some to add, but go ahead.
Oh, okay. Well, what's surprising? Well, I tell you, so I think what is amazing to me is what is possible, the amount of, the degree of benefit we can achieve through these analytics. The idea that we can use image classification of many, many different types of defect in our die and use an algorithm to do that more accurately than engineers with 15 or 20 years experience doing it is quite amazing to me as an example. And the ideas that are generated from our data science and big data community are always surprising and amazing, and that they have this potential value. And so many of these projects do create these benefits for the company. That to me is always surprising.
I would add that our performance is always, something that gets measured a lot. You're a manufacturing person in a company, all of your performance is being scrutinized constantly, as it should be. And our improvement in performance over the last 3 years has been, we've accelerated our improvements way beyond what we did the previous 10 years, actually, in our ability to solve problems faster and do so with less resources. So I've been very impressed with our engineering teams being able to consume this data, and there's just a huge appetite from our engineering teams with all of this data available. You can imagine part of the surprising challenge is channeling that energy appropriately, because there's so much data now and so much opportunity for people to data mine that you want to make sure that we're turning the focus on the biggest problems and putting the discipline we need in the organization to use the data in a way that they're solving the most difficult problems that will add the most value.
I'm actually going to take a moment and throw in a question as well. Leading off of that, you'd mentioned top priorities and outputs being things such as, better costs, higher quality, better yield value, efficiency, whether system or the tool, predictive maintenance, better OpEx, I think somebody mentioned as well. And I want to turn it over to Maciej. So is what you're hearing here?
Tremendous amount of imagination, innovation that's going into what additional sensors should we be looking at here. So if we're not able to catch a defect, we're not able to catch a problem with existing data that we have, how do we create data that will allow us to do that? And that's where some of the camera or visualization of a process will help, or the vibration on a tool, or acoustics and things like that have come, is the typical sensors we had on flow rates and RF hours and things like that were not sufficient to be able to catch some of these mechanical problems that we needed to be able to catch. And so visualization and acoustic type of data were very useful in doing so.
Thank you.
Maybe just two.
I'm intrigued to hear about your self-repairing tool.
Well, in fact, I was just going to add on. I mean, maybe I'll talk about the self-repairing tool, but Wayne talked about sensors, but he also in his opening talked about kind of the need for more knobs, on equipment. So one of the challenges we have continuously is a customer comes and says, we've now determined this is the source of our problem. We have to have some way to know how to adjust the tool. And so, not only are we working on big data, we then learn, where do we need to put knobs. And we have processes today that can take, as you heard, the output of, say, the litho step, and we actually can have a tool which can correct the next process step to produce a better result. And that's all the result of having the right data and the right algorithms that have been generated from a massive amount of data. And so those are self-correcting processes to produce a better result. From a self-repairing tool, we're really just at the very infancy of this, but if you can predict that a part inside the tool is going to fail, obviously the ideal case is that the tool would have access to that part and be able to replace it. That's not going to work for everything, but we do have the first cases of a part that is replaced quite frequently, maybe every few thousand, maybe every 10,000 wafers. And so we've designed the tool to have that part available to our internal tool robotics. And if the big data, the algorithm indicates that that part is wearing out, we would have the tool itself go get the new part, install it in the chamber, and you save yourself having to take the chamber down, and that chamber opening and recovery time can be 24, it can be a 24-hour process. And so again, it's about trying to have the tool more available to the customer, and that's a capital utilization. It's an output improvement opportunity.
Do you disclose whose sensors we use? Sorry.
Whose sensors we use? I probably would disclose if I knew, but I mean, we have a lot. I mean, we have so many sensors in the tool. It's not from any one company.
Can we go back to visual defects again for a little bit? I think visual defect classification by algorithms and the engineers believing all of that is a huge thing that in radiology, for example, right now is a problem that people have been working on for quite some time. And believing that the doctors are going to believe the algorithm seems like a little bit of a far step. What's more of that story?
Yeah, I think the interesting part is with some of the technology we have, we've had for many years auto defect classification capabilities off of inspection tools. And the problem is with visual data, it's difficult sometimes to get, you have to do a lot of training on the tool to get it to understand that. With the ability then to take that data now that's an image and then digitize it and compare things, you have another level of capability to really understand how to classify. So I'll give you an example. We have some of our defects might be a scratch on a wafer that goes to a certain angle. But if we know how our tools perform upstream from that, we can quickly identify which ones would have handling that would move in that direction. and then you can identify it's these 4 tools, and then you can go back and look at wafers that were last inspected off those tools and see if it's starting to trend that direction. You can quickly identify that, throw it up in the front of the screen for an engineer, and then they're not having to do a lot of the analytical work that they had to do before to try to figure out where that was coming from. The other thing that they're able to do is then take defects then and do that training more effectively to say, this type of a defect is always coming from this process. And some of that, rather than it just automatically shutting down a tool, it will flag an engineer in some cases on a mobile device where they can then look and make the call themselves. But so you're right, it is something that engineers typically are skeptical of this type of thing initially, but as they get more comfortable with it and as they're involved in the training and in those algorithms, I think the key is to involve the engineers in those solutions so they're not just taking the output of something that they weren't involved in. And the more you do that, the more they buy into it and the better the results are.
It's internal collaboration, not just
that's
across
right.
the industries.
Sure.
Yeah, I'd like to add a little bit more to that if I could, to your question about how do you gain that trust with the engineering community. In this particular example, the team had a collection of defects that they showed a panel of engineers. They asked them to classify them, and they observed the variance in the room of how engineers, the types of defects that they classified. And then they presented the computer results. And after discussion, the engineers had agreed that the computer was actually more accurate and had settled in on a more concrete view of the types of defects available. So that's one way that we work to build confidence in some of these machine learning models.
Any
Was
other-
the computer wrong at the beginning?
I will say I think that's true half the time, Tim. I mean, it's not 100% the case,
Sure.
but I think that those are the things. I think the key is that they need to be involved in the activity. Otherwise, just believing something is really hard for an engineer to want to just take an input and then go do something. They want to be able to be involved in the solution space.
Any other thoughts on? Yeah.
Quite often, I think if we're not careful, we will end up with a competition between a human and the
there you go.
computer, right? But I think what I think you've heard is that I think the right way of doing this is just when you think about all these engineers, I think they have decades of knowledge, right? And what I've seen a lot of companies do is actually tapping into that knowledge and including engineers into the process of designing the tools and optimizing the tools, right?
Sure.
And as a result, they are part of the solution versus just viewing it as like a machine's going to replace my job, right?
That's right.
I think that goes to all the activities that Singapore is doing to, it sounds like, train the new force and then also retrain existing. Yeah.
Precisely, I think you definitely need to bring your existing workforce into the development program because they are part of the knowledge base that you need to tap into as you do the training and so on. So.
And we've observed that some of the best data scientists we have at Micron were engineers. This was their focus. They loved solving these problems and working with the data, and they had the aptitude and desire to learn, to develop new skills. And so I think that's another way to create a winning team.
What's the right word I'm trying to think about? We're pattern recognition machines, basically, which the algorithms are. But we also have the ability to look forward into the future, project into the future, which is what perception. Is that right? Are we there yet with the algorithms, or that's something still coming?
That's a big question.
I mean, that's the promise of AI, right?
Yeah.
The predictive analytics.
Yeah.
Well, I think those are models that are much more complicated than other models are, but the predictive type of nature of these things are a lot more complicated. So I would say we're getting to the point where we can take data off of tools and understand after a failure to go back and analyze what the fingerprint was and then feed that forward into an algorithm that allows us to predict. But I would say that's been just in the last 6 months that we're really getting to the point where we have some wins in that space. It's pretty complicated, and I think that's what I'm looking forward to being able to do more and more as we get better at all of these data analytics and algorithms, but it's still relatively new for us.
I heard the singularity is coming in 2027 this month.
What's the exact date?
That's the new Y2K. What other questions can we bring, maybe go in a different direction or expound upon anything we've discussed? Okay. Well, I have one for you, Son. Is how did Singapore decide to go down this journey in the first place, and were there any challenges you had, or was it such a great? You want to expound upon that a bit?
Yeah, I mean, I mentioned earlier that we do have a substantial manufacturing base, and just like the US, I think our cost base is also not cheap. I mean, we've been out there to be the cheapest place on earth to do manufacturing, and therefore then the question is, how do we make sure that the companies and the plants there in Singapore can be competitive? And I think our answer is definitely to help make sure that the plants upgrade and be the best that they can be, and be the most connected they can be, and the smartest plants that there are out there. And which is why we went into the three things that I spoke about, whether the ecosystem, the technology, and the manpower.
That's good, thanks. So, okay, last couple questions. Do you want to go first, and we'll go to you, and then we'll do some final thoughts here as we wrap up the session.
Given the fact that the manpower constraints are not a country-specific problem, I'm curious as to how companies like yours and others are engaged or not in education at, say, the university level and pre-university level. And are you doing enough? Or are you just hoping these data scientists will just be churning out?
You guys are collaborating on that with universities.
Yeah, we are.
Maciej, do you want to start with that?
I can start. And I think that you're absolutely right. I mean, we, us and many other players in the industry, we work with educational institutions on sort of honing the curricula. And I think you've heard examples, right? That and it's a win-win for university, for students, and for us, because we actually getting the better qualified people, right? So instead of generic, let's say, knowledge, they actually have a specific knowledge in our field. The university actually gets the better placement rate and more targeted folks, and of course the students themselves are better prepared. And I mentioned it earlier also, we are investing heavily in sort of apprenticeship kind of a model also, right? So, because we believe that that's again a win-win, because in some way we get to sort of see the student sort of we try before we buy in somewhere, right? And the same for the student, they're actually getting practical expertise in addition to just theory. And lastly, I think as you mentioned, you cannot just start at the university level, right? So STEM education is key. And at Cisco, we, for example, run Networks Academy, right? When we educate high schoolers and even earlier ages. So but I think that across the industry, I think you see very much all of us investing heavily, and it's not just because we believe it's the right thing to do, but it's also in a self-interest. We have to get the right qualified candidates. I mentioned earlier, I think in the U.S. and Western Europe alone, I don't know about Singapore, but we have tens of thousands of unfilled jobs in manufacturing because we can't find the right candidates.
Last thoughts on that?
Yeah, I would add that more and more of my time and my senior technical and leadership resources are spending time in the universities, working with professors on curriculum, but also working collaboratively on projects. We've got some big data science projects that we're working with some of the universities in Singapore as an example, so that we can make sure that we're collaborating, using some of that intelligence and capability within universities to also add resource and manpower to what we're trying to accomplish in big data.
I think that the problem today in manpower is so acute that you just need to tackle it at many levels.
Right.
I mean, the university, the curricula, definitely. One of the other things that we've been doing in Singapore is also creating what we call short conversion programs. Maybe bring someone from a civil engineering background into data science, for example. I mean, maybe a stretch, but a 6 months course or a year maybe,
Yeah.
bring it close to being functional and so on. And then the final thing that we are trying to do with respect to manpower is to persuade a couple of companies to hire more, especially at entry level, than they need and at the government's cost, so that hopefully that gives them a bigger pool and train a bigger pool of people that have experienced it. Hopefully then, as their careers progress, can go and do different things within the companies or other companies.
Thank you.
I would just point out we have Tom from SEMI here as well, and one of the initiatives we just launched 2 weeks ago in Silicon Valley was a high-tech university, high school was involved in this. It's a program in San Jose State where actually, going into bodysuits and experiencing the semi industry firsthand. It's something we've been running in Boise with our organization, the Chip Camp and our foundation for many years. So we're excited to bring that to Silicon Valley as well.
Okay, last question, then I'll pose to you guys a question for finishing comments,
Yeah,
please.
my question was, so a semiconductor plant is a little different than other types of manufacturing, that you basically have people who buy, you get raw materials, you have people who buy your equipment, you manufacture, but you have a broader supply chain, you have some components, subcomponents, et cetera, in other factories. How well do you think this would scale to, have multiple factories, and be able to get the data, analyze that, and do the same kind of thing you're doing?
Across our factories, or?
Well, I'm
Across
saying-
different types of factories, I think.
Different
Types of manufacturing.
Okay, yeah, I can give you an example
Your
of
case
that,
where you
yeah.
sort of have a smaller ecosystem.
Yeah.
Other people, like they sort of make consumer electronics or something like that.
Yeah, sure. Well, we also, as an example of, I think, of how we're making that work is across our front-end and back-end manufacturing. So our back-end manufacturing, we have a lot of subcons that do back-end manufacturing for us, but we have internal as well. And being able to take our data from front-end and work all the way through packaging and test and work across that value chain allows us to feed data also into our back-end facility. So we're not just doing it within the fab factory that we're doing, taking our big data and making adjustments or understanding how to tune our process. But for example, on a chip count where you're doing like an 8-die stack, you want to make sure you're reaching back into the data in the fab to understand which die are going to be most likely not to fail on that 8-die stack, so you don't kill 7 die with the 1 die that failed. So we'll feed that data forward. And so within our factories in the back end are a lot more manual type of processes. There's some automation there. But even across, highly automated environment like a front end, like kind of lights out, and into a more manual factory environment, we're still able to use the data to be able to optimize our process across those two environments. I don't know if I answered
And
your question.
One thing
but
we've seen, because we look at a lot of different industries here across Ross and Sullivan, is that we definitely see this at a more top level, more broad level, but still one that involves data analytics and is looking up and down the value chain. So using that information to help understand if materials are going to be delayed, for example,
Sure.
or
Predict your, other things.
exactly, or even using some level of your hose on the Twitter feed to understand if there's changes in social changes that might change demand of a product down the road, and then downstream as well to your supply, around that supply and to your end user and to your customers.
It makes sense to scale.
How's it going to go back? Yeah. So definitely, and creating like a network of distributed manufacturing and above and beyond that. So I think it's very applicable.
I would
Great
add
question to add,
to
too.
Roberta's
Yes,
comment
please.
that out of manufacturing Fortune 1000, I can't think of any manufacturer who's not involved. Right? There's a question of just of the degree.
What level?
Yeah.
And level of readiness there, right?
Yeah.
That's right.
Some are just, like I said, if you look at a chemical plant, most of them are still trying to install all their Wi-Fi across the factory and so on. So it varies very much.
Sure.
By industry. Great. Well, thanks everybody. We've got let's take maybe a minute or two each, and I have a question just on some final thoughts. Changes in the last 3 years, 5 years, even the last 6 months, largely technical, but on business model as well. I want to know what your thoughts are on what's the most impactful change that you've seen just in these last couple of years. What's the most disruptive thing that you think we're going to we're going to see, or that's going to make a real change in the market. And Tim, we're going to start with you.
Perfect.
Because we haven't heard from you very much up until now. So what are your thoughts on recent, technical or business model changes that you think are going to be disruptive in the next year or two to come, or the potential to be?
Yeah, well, I think that, I guess very specifically to this point, in terms of how it has an ability to disrupt, is really about the cost model for manufacturing. When we think about how many times we come to this SEMICON West show and we hear about Moore's Law and whether Moore's Law is slowing or ending, and I think we've generally demonstrated with our partners that there's almost no limit to our ability to technically scale devices. And the bigger challenge is that many of the solutions to these technical challenges are very complex, they're very costly. As I mentioned, require a lot of labor and manpower at the development phase. And I think that this Industry 4.0, the ability to bring big data to the manufacturing complexity and cost problem actually is at least one part of the solution to continued scaling. And we talked a lot about that today, but it's about how do you manage tighter process windows to enable node-to-node scaling? How do you manage the cost issue that becomes such a challenge every time we try to shrink? So, I think that, I don't know if it's disruptive or it's evolution, but I think we're at a tipping point where this big data and machine learning initiative becomes a key part of the technical scaling Moore's Law extension.
Interesting. Thank you. Good. Thank you. Tim?
So as a practicing leader of data science, I think one of the exciting things in machine learning is this concept of automatic machine learning. So there's a handful of startups out there that are trying to automate the job of the data scientist, right? How do I grab data, carefully select the right modeling techniques and produce a solution? I think that's very fascinating. It has the potential to democratize data science and machine learning. I think there's a lot of risks that come with it. I don't think it's easy. It's not going to happen overnight, but I find that very fascinating as a potential down the road of having solutions that can develop themselves.
Indeed. Yi-Hsen?
I take the view that with the current wave of Industry 4.0, a lot more of manufacturing is becoming digital. A bigger part of it is happening on the digital front, the software. But one of the big implications that I think gets forgotten sometimes is the acceleration of the innovation cycle. Compared with innovation on a hardware scale where you don't make something, it takes you a whole lot longer to get the innovation across. But when it comes to software, the speed at which it says how fast can you code, and how fast can you build a model, and that inherently drives a certain acceleration of innovation that's going to be quite scary for those who actually manage to leap ahead and get the digitization going.
Be very disruptive. Thank you. Maciej?
I think for me, what's really exciting is that it's not only in this industry, but across all the manufacturing. So to make a cliche statement, every company is becoming a technology company, right? And from that perspective, whether you're in the car manufacturing or consumer goods or chip manufacturing, I think there's different levels. But I think that we're basically seeing the technology in the manufacturing industry consolidating and converging, and that's sort of exciting because it's one of these things that even 10 years ago was hard to imagine.
I would just add to what Tim had to say that, again, I would state that in the last 3 years, we've accelerated our improvements faster than the previous 10. So we've tripled the rate of improvement just in the last 3 years, and I think it's continuing to accelerate. So yes, it's helping us to solve these difficult cost problems as we scale our technology. But the other thing I would say is our engineers are spending more time really truly innovating and not just solving the same problem that somebody else has already solved before, because they can turn that into a machine learning event, an algorithm that will catch that problem, and they're not having to spend time on that anymore. Now they're trying to solve problems where we haven't solved them yet. And so I think that's one of the key things is the innovation. You can work on things that haven't ever been solved before instead of working on something that has been solved 100 times and is repetitive.
Okay, great. Well, thank you. Thank you very much, gentlemen, for your thoughts today. And thanks everyone for attending. I'm sure people will be available for comments, and I think there's charcuterie and beer and wine as well. So thank you all for attending today.
Thank you.
Thank you for the opportunity.
Thank you.